What are ground improvement techniques for earthquake liquefaction? Have you ever wondered how engineers protect buildings from the dangers of earthquakes? One major threat is earthquake liquefaction, where saturated, loose soils lose their strength and act like a liquid during shaking. This can lead to severe damage, such as sinking or tilting structures. To combat this risk, various ground improvement techniques are employed to strengthen the soil and enhance its resistance to liquefaction. First up is soil densification. This method increases the density of loose soils, which reduces the space between soil particles. By doing this, the potential for liquefaction decreases significantly. Two common techniques for densification are vibrocompaction and dynamic compaction. Vibrocompaction uses vibrating probes to rearrange soil particles into a denser configuration. Dynamic compaction involves dropping heavy weights onto the soil to compact it. These methods work best in granular soils and are typically effective at shallow depths. Next, we have soil stabilization. This technique involves mixing soil with cementitious or chemical binders to solidify and strengthen it. One popular method is deep soil mixing, where binders are injected and mixed into the soil to create soil cement columns. This increases the soil's strength and stiffness. Another approach is grouting, which involves injecting grout materials into the soil to fill voids and bind particles together. Variants of grouting include compaction grouting, permeation grouting, and jet grouting. These methods help reduce soil compressibility and increase shear strength, limiting the potential for liquefaction. Reinforcement is another key technique. This involves adding structural elements to help transfer loads and improve soil behavior during seismic events. Examples include stone columns or rammed aggregate piers, which are vertical columns of compacted gravel that densify surrounding soil and provide drainage paths. Rigid inclusions, made of concrete or steel, bypass liquefiable soils and transfer loads to stable layers below. Geoconcrete columns and grouted impact columns are also used to resist lateral spreading and cyclic degradation during earthquakes. Drainage and dewatering techniques are essential for reducing excess pore water pressure during shaking. Installing drains or drain piles allows water to escape quickly, preventing pressure buildup that can lead to liquefaction. Often, a combination of these techniques is used to optimize effectiveness and cost, especially for critical infrastructure or sites with complex soil conditions. Applying these ground improvement methods is vital to mitigate the risk of structural failures during earthquakes caused by liquefaction. Proper site investigation and engineering design, tailored to local soil conditions and seismic hazards, are key to ensuring long-term ground stability and public safety.